Hello everyone. Today we are going to discuss about inter-process communication in shared memory model. Now first let's discuss about what is meant by inter-process communication. Now when we talk about processes, we have two different types of processes, namely independent processes and cooperating processes. Now when do we call two processes as cooperating processes? When one process is going to affect or it is going to be affected by another process, then those processes will be called as cooperating processes. And if a process is not affected or it is not going to affect another process, then that process is called as an independent process. So whenever we talk about processes cooperating with each other, there needs to be some kind of a synchronization between both the processes. Now, what is the need for having cooperating processes? What is the benefit of cooperating processes? We have four benefits. The first one is when we say that two processes are cooperating with each other, information can be shared, computation will be speeded up, you will have modularity, and it becomes convenient to use. So these are the four reasons why we go in for cooperating processes. When we say we're going to have two processes that are going to cooperate with each other, then definitely we need to have a communication between the cooperating processes. That communication is called as inter-process communication. So whenever we say or whenever we talk about inter-process communication, that means the processes involved in inter-process communication are cooperating with each other. Now coming to the two models of inter-process communication. We have two models, namely the first one is the shared memory model and the next one is the message passing model. We will first discuss about shared memory model in this video. In my next video, we will discuss about inter-process communication in message passing model. Now let's discuss in detail about the shared memory model. Now, when we take the shared memory model, look at the second diagram. Look at the second diagram. The second diagram depicts the shared memory model. We have process A and then we have process B. Now, both these processes are cooperating, which means there must be an inter-process communication between process A and process B. Now, the box that is depicted here is the main memory. A part of the main memory, all of us know, will be occupied by the OS. So the kernel of the OS is loaded in the main memory. Now, apart from this, whenever A and B want to communicate with each other, there will be some location in memory which will be shared among both processes A and B. And through this shared memory only, inter-process communication is going to take place. So whatever A wants to communicate with B, it will be put into the shared memory. And similarly, B will be able to access the content of the shared memory. So this is the basic of the shared memory model. Let's now discuss in detail about the shared memory model with the help of the very famous producer-consumer problem. Now, when we take this producer-consumer problem, this is the main paradigm for cooperating processes. We are going to now consider our two processes that are going to be involved in inter-process communication. One as the producer process and the other one as the consumer process. So we are going to have two processes. One is the producer process. The other one is the consumer process. The job of the producer process is to produce information, and the job of the consumer process is to consume the information produced by the producer. And now we are going to use a buffer wherein this buffer is going to act as our shared memory. So this is the shared memory that we are going to consider, the buffer. Hence, here we can consider two types of buffers. One could be a buffer with a definite size, or another could be a buffer with an indefinite size. That is, there is no limit for the size of the buffer. Such kind of buffers we call as unbounded, and buffers with a limited size we call as bounded. Now, let's consider this example with a bounded buffer case. That is, we are going to put a limit on the size of the buffer. So it's going to be a bounded buffer producer-consumer problem. This is what we're going to now deal with. Now, here, when we talk about the shared data here is the bounded buffer, the buffer which is going to be shared by the producer process and the consumer process. So, we are going to now see the pseudocode of the producer and the pseudocode of the consumer and how they cooperate with each other in such a way that the communication takes place effectively. Now, for that purpose, we are going to have two variables, integer variables, in and out. In will be used by the producer process and the out variable will be used by the consumer process. Of course, we have our shared memory, which is the buffer. And since we are using a bounded buffer, we are going to define the size of the buffer as in buffer size. So buffer size depicts the size of the buffer. Now let's see the pseudocode of the producer process. Now this is the pseudocode of the producer process. Now, how we are going to consider is we are going to take. We have assumed that the buffer size is going to be 10, which means the buffer can hold a maximum of 10 elements. Beyond that, it cannot hold. And as the producer is going to produce one item, the consumer is capable of consuming that item. Care must be taken. If you want a proper communication to exist between the producer process and the consumer process, care must be taken in such a way that the producer process produces items and puts them into the buffer and waits until the consumer consumes it before it produces the next item into the same location, which means the producer process should not lead, that is, should not produce items in such a way that it does not lead to loss of data. Similarly, when you take the consumer process, the care must be taken to write the code of the consumer process in such a way that the consumer process is responsible for consuming the items produced by the producer. Hence, care must be taken that the consumer process does not consume the same item which it has already consumed. Therefore, care must be taken such that duplication of data does not occur. Now, producer process is capable of leading to loss of data and consumer process is capable of leading to duplication of data. Now, if loss of data or duplication of data occurs, then we say that synchronization between the producer and the consumer is lost, which means the inter-process communication is not effective. So, therefore, we must make sure that there is neither loss of data nor there is any duplication of data, and the producer and consumer communicate with each other in such a manner that they achieve proper synchronization. Now, the reason why we have used in plus 1 mod buffer sizes, we are going to consider our bounded buffer as a circular array. That is, the first element is going to be in location 0 and the last element is going to be in location 9 since the buffer size is 10. So once the producer puts an item into location 9, the next place that the producer will put the item is into location 0. So that is why we keep track of the counter using the mod operator, mod buffer size, wherein when we reach the last location, again we'll be able to come back to the first location. So what is done in the producer process is you don't allow the producer to produce items if the value of the in plus 1 mod buffer size is equal to out. That is, when you put a lock on such a kind of a condition, then there will not be any kind of a loss of data. And here, the next item that is being produced will now be put into the buffer at location in, and in is again incremented by 1. Because it is considered as a circular array, we are using mod buffer size. So this will keep on, these two statements will keep on executing as long as the producer is producing new items into the various locations of the buffer. And when you find that the buffer becomes full, which means the producer cannot produce further items until the consumer has consumed, then the producer has to stop and lock itself and wait till the consumer consumes at least one item. Now, coming to the code of the consumer, like how we had the in variable for keeping track of the producer processes items, here we are having the out variable. And similar to this, the same thing that we are going to use is we are going to use the mod buffer size because our buffer is considered as a circular array. Now, we will not allow, care must be taken in such a way that we should not allow the consumer to consume the same item. Duplication of data must not be there. Hence, what we do is we put a lock on this condition. That is, when the in value and the out value are the same, we don't allow the consumer to consume. So these two statements depict how the consumer is consuming and how the consumer is moving forward to access the next item in the buffer. So we will put a lock for the consumer when we find that the in value and the out value are the same. So we will only allow the consumer to consume if in and out are not having the same variable. So by writing the code in such kind of a manner, we are able to achieve proper synchronization between the producer process and the consumer process. So this is how inter-process communication is established in the shared memory model, and just an overview of the whatever we saw. So in the memory, a part of the memory will be shared among the processes that want to communicate. This is the shared memory model. And the communication that is going to take place will be completely under the control of the user processes and not the operating system. The control is over the user process and the OS will not take control. And the issue that lies in the shared memory model is in providing mechanisms that will allow the user processes to synchronize their actions when they access the shared memory. So that is the major issue that is prevailing while providing shared memory model for IPC. So with this, we will wind up this video, and we will see how inter-process communication takes place in the next model message passing model in our next video. Thank you.